Roller coasters offer a thrilling experience by spicing up the way our bodies experience forces. Roller coaster trains speed up and slow down as potential energy is transformed into kinetic energy and vice versa. Older rides crank trains up slopes using a lift or chain, building the anticipation before gravity takes over, sending riders shooting down the hill. Some modern rides also use hydraulic or electromagnetic propulsion systems to give riders a gravity-defying boost.
We're here to ride probably what's one of the best woodies, that's a wooden roller coaster, in the world. In fact, wooden roller coasters are differentiated from steel coasters because the tracks they're on. So we're still on steel, but it's the steel tracks are on wood and also in a wooden structure. In fact, this wooden structure is made from Canadian spruce, I think it was called, wasn't it? Pine, Canadian pine, specially treated Canadian pine. Now, you can never get the biggest, the highest, the fastest coaster when you're making it out of wood, which is really hard when you're trying to market a ride and get people on it. But once you get on it, then you start to see why they're so popular. Because the wooden structures are designed to twist and sway. In fact, if you look over there, you can see some of the steel coasters. There's one of the Eurofighter styles, but it's nothing like this. This ride can actually move up to a foot as it sways, as the cars go around it. And you'll just see why it's the most rickety, rip-roaring ride around.
In everyday life, most of us don't really think about gravity because we don't notice its constant downward acceleration of 9.8 meters per second squared. But on a roller coaster, you experience frequently changing forces. During rapid descents, as your acceleration approaches that of gravity, you start to feel weightless. At the bottom, you suddenly squash into your seat and feel much heavier. The greater your acceleration, the larger this so-called G-force you experience. You feel similar lateral G-forces on the corners as your body continues trying to move in the same direction while the train is veering the other way. Banked tracks prevent you from slamming into the side of your car.
Did you know that our thrill levels are closely linked to the changes in G-forces? So the levels of arousal, we feel that's how excited you get, are completely linked to the changes in the G-forces on any ride. And that's the thing that really intrigues me when I'm designing a thrill ride.
Thrill seekers also love that feeling of almost floating as a train drops away as it goes over a hill, where your body momentarily tries to carry on moving upwards and forwards. Top tip, you'll experience the maximum airtime effect if you sit in the front or the back of the train, which moves over the hill faster than the middle cars do. Perhaps the most fun are the loops. As you spiral upside down, centripetal force is pushing the car towards the centre of an imaginary circle. You are not only relying on a seatbelt to keep you in your seat, thanks again to inertia, your body's resistance to a change in direction. As the train curves, your body wants to continue travelling in a straight line. So even when upside down, you feel yourself being pushed into the seat. Today, roller coaster designers are creating new experiences using virtual reality.
At Thrill Laboratory, we've been using virtual reality headsets because it turns out that our experience of G-forces isn't just the forces that are being applied to the body, it's actually what we see as well. And if we can make people believe that they're doing more extreme forms of movement, we find that the levels of arousal actually go higher. So if we use the accelerometers inside the headset to work out what the G-force is, let's say it's 2G, we design a virtual reality experience that makes you think that you're doing 4G, then your arousal levels go up twice and your thrill levels also go up twice. So we're working on applying virtual reality headsets to existing roller coasters and old fairground rides to ramp up their thrill levels. And it all comes from a basic and fundamental knowledge of physics.
Find out more by reading the article Twists, Turns, Thrills and Spills, The Physics of Roller Coasters. Available now on the Physics World website.